Now inside of 2 minutes until liftoff of Relativity's Terran 1 rocket. Seeing some views under the engine section of the Terran 1 where the 9 Aeon engines are awaiting ignition. 1 minute 45 seconds. The terminal countdown sequence will begin at 70 seconds before launch. That will begin a final check of all launch commit criteria. The countdown is holding at 70 seconds now. This is a hold point that is possible for the team to use if they need to. This is where the countdown held on Wednesday's launch attempt. This hold was apparently called due to a violation on the range. Relativity reports there is a boat in the restricted waters near the flight corridor in the range area. So the range is called a hold on the countdown. The range is currently red. The range is responsible for public safety around rocket launches here on the Space Coast of Florida. It's run by Space Launch Delta 45 of the U.S. Space Force. The range team is currently working to see if they can clear this boat, which has wandered into restricted waters under the flight corridor or around the launch pad here at Cape Canaveral. They want to make sure this vessel is out of danger and out of the flight path of the Terran 1 rocket. They want to clear this area in case there's a mishap or an accident that causes any debris to fall into the ocean. The countdown still holding at T-minus 71 seconds right now, just prior to the start of the final terminal countdown sequence, which begins at 1 minute 10 seconds prior to liftoff. While we're waiting, if you haven't done so, we remind you one more time to please hit the thumbs up or the like button if you haven't done that already. It helps us get as many people watching this exciting launch of the first ever 3D printed methane-fueled orbital class rocket. Also, a big thank you to those of you Relativity reports the boat apparently has been cleared out of the range area, according to Launch Director Clay Walker in the Launch Control Center here at Cape Canaveral. We're standing by for an updated target launch time and when the clock will be able to resume to tick down the final 70 seconds until liftoff of the Terran 1 rocket. We want to thank those of you while we're waiting. Thank you for your support in the Super Chat. We've had several of you donate in the last few minutes. Your donations help us support our coverage, bringing you live video like this, independent coverage of launches here at Cape Canaveral. The countdown will pick up in 60 seconds, according to Launch Director Clay Walker. The new target launch time is 2:42 p.m. Eastern Time. The countdown clock has resumed. Inside of 1 minute, the flight computer is in countdown mode. The flight computer on the Terran 1 is controlling the final 60 seconds of the countdown. Engine start will come at T-minus 6 seconds. Final go has been issued for launch by Launch Director Clay Walker. 25 seconds. T-minus 20. T-minus 10, 9, 8, 7, 6, 5. We're going to stand by for engine start. Engine start. It looks like there's been an abort. There was an abort at engine start, after engine start. So the rocket has not lifted off. The rocket remains on the ground at Launch Complex 16. standing by for updates from Relativity Space on the next step here. A engine abort, such as the one we saw, is not entirely unexpected for the launch of a brand new rocket. Obviously, the Terran 1 remains vertical, safe, looks intact out at the pad. So right now there are steps underway to safe the vehicle and secure it after this last second abort.
All right, I'm hearing from Mission Control that we're currently assessing vehicle health to confirm if we can do a recycle today and try this thing one more time.
Announcement on countdown net. This is the LD. We aborted terminal count on a launch commit criteria violation at T-minus 0.5 seconds prior to liftoff. We're safing the vehicle and assessing recycle opportunities.
As you heard, once again, we had a violation with our launch commit criteria, which is why we had an abort shortly before liftoff. The team is continuing to assess vehicle health to confirm if we can have a recycle today. As a reminder, we're currently at 14:50 Eastern Time, and our launch window is open until 1600 Eastern. So our teams are currently assessing any recycle opportunities that we have during this time. You'll see an occasional cloud coming out of the transporter erector or the black truss structure there. That is just because we're keeping our propellant topped in case we can re-attempt a launch before the end of the window today at 4 p.m. Eastern. As you can see, the T clock rolled back. We are still working on a recycle, so we'll keep you updated as soon as we have confirmation. All right, the T-clock is rolling again, everyone. We just have an updated launch time of 15:55 Eastern. Once again, 15:55 Eastern in just under 44 minutes. We're going to keep going. I just got an update from our engineers and mission control. We are updating the T0 time to 1600 Eastern. Once again, that is 1600 Eastern. T clock is rolling.
For those of you that are tuning in today, we're going to take a moment again to introduce ourselves. My name is Rachelle Aniceto. I am the Chief of Staff for the Vehicle Architecture and Technology team.
And I'm Arwa Tazani Kelly, Technical Program Manager for Test and Launch here at Relativity Space. Now, ahead of Terran 1's liftoff, we invited some of the most influential voices in the space industry to curate some questions from you all on Twitter about our journey to launch. We appreciate the time that Michael Sheets, space reporter at CNBC, Eric Berger, senior space editor at Ars Technica, and Tim Dodd, the everyday astronaut, took to answer your questions. Let's take a look.
This question comes off of Twitter from Danny Stover. Many launch companies fail their first attempt. Will Terran 1 reach the same fate? What makes Relativity's approach different? I want to hear, Michael, what do you have for that one?
Many companies failing their first launch attempt is, I think, a great example of the high risk aspect of the development process. And I think that's one thing a lot of people need to keep in mind is there's along the way to development, even before launch, there's all these milestones that you're trying to get through, including, as we've seen recently, static fire. So you pass those milestones, you get more data. As you move closer and closer, the end goal is, can we not just get into space, not just get into orbit, but deliver into the targeted orbit, get to the place we want to actually be? And I think a nice analogy of it is like ordering an Uber. You want an Uber that's going to get you the closest to your destination, ideally your front door. But if your Uber is dropping you off, a couple miles away, you're probably not going to continue, using the app anymore because you're going to try to go with a competitor who's actually getting into that ideal orbit. So will it make its first attempt is that open question. And I think I really want to stress the development side of where the company is, because people see failure at kind of any stage and they go, oh, this is a wash. But it's really important to understand that ultimate goal of an intentional specific orbit.
I'll answer the question a little bit more bluntly. I do think Relativity probably will fail on their first launch attempt. If you look back at no new space company has ever reached orbit on their first flight attempt. You had Rocket Lab failed, SpaceX failed on their first attempt, Virgin Orbit failed, Firefly failed, ABL failed. And so, it's the odds are against them, and more credit to them if they succeed. And I also think that the 3D printed nature of the structure is a big test. Are you going to be able to see that get through max Q? And then there's some more complex elements on the Terran 1 rocket that you might see in a more traditionally developed launch vehicle. And so I think seeing a nominal first stage performance would be a pretty big win for Relativity. And I'd love to see them get to orbit on their first time out. I just think historically the odds are pretty long against it.
Yeah, I'm definitely with Eric there. I realized just recently that, the Pegasus, when it first launched, was one of the only rockets to successfully make it to orbit on its first launch. So, that was definitely not by any means considered new space by today's standards. But realistically, like Eric said, the odds of being completely successful on the first round is statistically about zero. So I'm just excited to see if they can get through the first big milestone. If they can, make it through max Q, if they can see stage separation. Each staging event is definitely one of those big unknowns until you do it for the first time. Can you light your upper stage engine? Can you, deploy your fairing? Can you eventually, if you get to deploying a spacecraft from, on orbit, that's the ultimate milestone, of course. But yeah, there's a lot of things between there and leaving the ground. So yeah, time will tell.
I think only of the companies that we talked about outside of Pegasus, and that was Orbital Sciences, and of course that was a solid fueled rocket, and most of which was not developed in-house like the commercial space companies of today. But of the companies we talked about, only Rocket Lab got to like a second stage engine ignition and flight, right, on their first mission.
Yeah, 21st century wise, that's definitely true. And I think another way to tackle this question is defining failure, because when you talk about many companies fail their first attempt, you need to understand the multi-step process of a rocket launch. And I think that's another important aspect where depending on how far they get towards their ultimate goal, will categorize whether this is a learning experience from a failure standpoint or this has a lot more to build upon. And every step that they complete during the launch is another check mark towards success.
Yeah, absolutely.
This next question comes from Han Tronics. With the capability of 3D rocket printing, will we see a day when rocket engines are a part of the ship structure such that their major components won't need to be removed, inspected, or replaced after every launch? I don't remove my engine in the car every 1,000 miles.
I think there's always going to need to be some kind of repairability and separateness of the components of the structure of the vehicle and the engines. I mean, there's just an inherent, physical moving parts. You have bearings, you have valves, you have components that just would need to be inspected on any vehicle. And if you completely integrate that into the structure to the point of not being able to remove and service it, you just really, you really limit yourself. Now, if you're talking about an expendable launch vehicle, there is the potential that integrating it could actually add potentially some reliability or simplicity or mass saving. So it depends on your overall goal. If you're talking about a reusable vehicle that you're flying over and over and over, completely integrating it to the point of not being able to even remove and service it is probably not the best idea, in my opinion.
I would just say that, this is an impossible question to answer now because we have to see if 3D printed rockets are capable of flying. And that's the great thing. What I love about the launch industry today is you've got all these companies trying different things, right? You've got ABL out there trying to basically build a miniature Falcon 9 as simple as possible, a modular approach, ship it and shoot it from a launch pad. You have, Virgin Orbit trying air launch. You had Astra trying to build the cheapest, perhaps less reliable rocket, and you got Relativity doing additive manufacturing. And so it's great to see all of these different approaches because we're going to try them all out, and it takes a real world test, I think, to get the right answer ultimately.
I'll do this one. This one comes from Kyle A. May asking, what other markets in the space sector or beyond do you see Stargate technology being applied in? I kind of mentioned it earlier. I would love to see, large scale additive manufacturing be used for, automobile prototyping, race car prototyping, especially. Oh my God, like the Formula One world where every year the cars have new restrictions and new rules and a new, set of rules to have to engineer by. Being able to at scale develop stuff with a 3D printer makes all the sense in the world. So I think that's a pretty no-brainer to be the automotive industry.
I think there certainly are potential other market use cases, but additive manufacturing, obviously predated Relativity, and they're trying to apply it in this really significant way with such enormous structures. And I think that's the fascinating aspect is you try out the technology behind the rocket in such a extreme use case where then other sectors can look, where can we apply this? Where can we iterate faster by implementing printing these as solid entire structures as opposed to different pieces that you put into whether it's for shipping or other large industrial components. You can see the kind of downstream effects of basically a demonstration of, hey, we can build a rocket with this type of technology. What else can't we build?
I think Michael's exactly right. There's been talk about Relativity since it was, almost since it was founded. Is this a launch company or is this a 3D printing company? I think, that once they sort of wrap their hands around spaceflight, they're going to be taking this technology into other areas. And we don't really know what those are. It'd be interesting to find out. Just for me personally, one of the big issues that we've seen in this country and around the world has been housing issues. And so I don't know if 3D printing these large structures could be applied to housing units or things like that. But it's going to be fun to find out where this technology goes.
That was a great video answering some of your questions on Twitter. Now we are at T minus less than 30 minutes from our launch with our updated launch T0 time of 4 o'clock p.m. Eastern. So that is 1600 Eastern. We're currently going to stand by from an update from Mission Control in the next few minutes. The go, no-go polling from Mission Control is coming up here in just a couple of minutes, around T-minus 16 minutes. We're going to stand by and continue listening in, awaiting that poll.
All parties all nets. This is the go, no-go poll for launch. Please provide concurrence to proceed in the launch operations with go, no-go. GC go. GNC. Flight software. Prop 1. Prop 2. Fluids 1. Fluids 2. Loads. Rock.
Ranges go.
OSM. RC.
RC go.
Vehicle. CE. LC. LC go. All parties are reported go for launch countdown.
All right, our team is being relentless here. We are not giving up, and we're going to give this one more shot with an instantaneous window at 1400 Eastern. As you heard, all parties have reported they are go for launch.
And just a reminder, 1600 for that launch. And as we continue to wait, let's remind you what we have inside of our nose cone. So we don't have a customer payload on board, but we do have our special memento, which is our first ever 3D printed piece from our Stargate printer. As we mentioned before, it was a failed print, but this is just special for us as we get to this moment. As a reminder, that piece is about 6.5 inches in diameter and weighs about 3 pounds, and it is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we added a machined centerpiece with GLHF and our mitosis logo to commemorate this maiden launch. We'll go ahead and tune back in to mission control and wait as we get closer and closer to launch.
T-minus 10 minutes, countdown sequence has started.
And you heard that call out. We're currently at under T-minus 10 minutes. And in the upcoming minutes, once again, you're going to hear several call outs from Mission Control as we go through the final pre-launch procedural steps, including priming of the igniters, final engine checkouts, transporter erection retraction, and getting that final go for launch for this attempt. Again, we're now pressing the tanks
Going to flight targets.
to flight pressures, as you just heard, and we're currently proceeding with our time of 1600 Eastern. This will be our last attempt for today, and it is an instantaneous launch window. Stage 1 will be transitioning to helium shortly.
Stage 1 pneumatics have transitioned to helium.
Once again, that means we're pressurizing the propellant tanks to flight pressures with helium. And as a reminder, during flight, we'll be pressurizing using autogenous pressurization. Tanks are pressing for engine chill.
Since we're getting into the business end, let's remind you about our launch timeline. Arwa, take it away.
So again, at T-minus 3 minutes, the transporter erector or the black truss structure behind the vehicle is going to retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will of course be on internal power. At T-minus 70 seconds,
Stage 2 igniters for flight targets.
the vehicle will go into terminal count, and this is again when the vehicle's internal flight computer takes control of the countdown. We'll then go into flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6, we're going to see that ignition one more time of those 9 Aeon-1 engines. So you'll see the flames, the blue fire, I should say, beneath the rocket.
Stage 2 igniters priming in.
And at T0, we'll have liftoff. At T plus 2 seconds, the strong back is going to throw back to remove the umbilicals and clear the path for the vehicle to fly. At T plus 12 seconds, we'll begin our pitch over program. And then at T plus 80 seconds, we're going to reach max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff. That is where the stage 1 engines will shut off, and it will be followed shortly by stage separation and Aeon vacuum engine ignition. Our second stage will burn for a little under 5 minutes. Then at approximately T plus 463 seconds, we'll get to second engine cutoff when that Aeon vacuum engine will shut off. And as a reminder, we do not have a fairing or any payload deployments for today's first launch. With that, we'll go ahead and sit back and listen back to Mission Control.
We're currently priming the igniters with gaseous oxygen and gaseous hydrogen. Again, our ignition system uses these propellants flowing across a glow plug. Less than 5 minutes away.
Stage 1 igniters priming in.
GLHF again is our maiden launch. So a nominal flight would have Terran 1 reach orbit today, but our main goal is to learn as much as we can about this vehicle and demonstrate the product concept. A major milestone would be for us to reach max Q today, the point of maximum dynamic pressure.
Stage 2 is on internal power.
And the
TE cradle disengaged.
TE cradle, there we go, disengaged. You'll see that cradle arm slowly start releasing stage 2 so that the strong back can retract. And you can see the engines gimbaling there. We're performing the final thrust vector control health checks on both stages right before liftoff. You can see stage one
is on internal power.
Engines there.
Strung back retracting.
And now that black truss structure will retract just a few degrees to prepare for umbilical separation. There it goes.
Stage 2 TVC checkout.
As we approach T-minus 2 minutes, just a reminder, the vehicle you're looking at is 85% 3D printed. Those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid air that we have here in Florida. That's why it condenses into vapor and it looks like clouds that are floating out. You'll also see the flare stack on the bottom right there. That is just used to vent out flammable gases. Next up, our range coordinator will ask the range for their final status.
Rock, report range status.
Range green.
We got confirmation. Range is green for launch.
Propellant topping closeout.
Flight computer and countdown. Announcement on countdown, that is the LD. We've had a abort in terminal count. This was a final instantaneous T0 launch window. We are going to be scrubbed for the day. Safing up the vehicle. Thanks for playing.
Our teams obviously gave it an amazing shot today, and we had high hopes for sending our Terran 1 off, but we're going to continue to take a measured approach so we can ultimately see this rocket off to max Q and beyond.
Once we have an update on the timing of our next launch attempt, we will share that via Twitter at Relativity Space. We hope you will join us again soon to see the world's first 3D printed rocket fly. I am Rochelle Aniceto.
And I'm Arwa Tizani Kelly. Thank you. See you next time.
That's one that will